Hello, my name is Shane LaChapelle, Product Marketing Manager in the ID Business Unit here at Cognex. The reason for this video today is that I want to introduce the newest member of the DataMan product family, the DataMan 50L. I think by the end of this video you're going to understand why you should be upgrading your single line laser scanners to the Cognex DataMan 50L. First I want to talk about where the DataMan 50L fits into the total DataMan product family. So the DataMan product family is segmented into two parts. There's the fixed mount readers and the handheld readers. Today we're going to talk about the fixed mount readers and exclusively where the 50L fits into that equation. So in the fixed mount family readers you have the 50L, the 300, the 500, and the 503. So the 50L really fits into our value add segment. And the reason we call it that is really we're targeting this at your single line laser scanners, and there's certain requirements for your application that we're going to try to tailor this to make sure that you're using it correctly. So really for the 50L we want to stay to applications where your code placement is consistent, where your field of view doesn't have to be too large, but we still have very high speed capabilities, and we have the same patent pending hot bars technology as we do on our 300, 500, and 503. So with the higher field of view applications, the higher depth of field, higher speed requirements, we can get to the medium and high end values, 300, 500, 503s as well. So just let us know about your applications. I want to talk about where to use the 50. We touched on it a little bit in the last slide, but really you want to make sure that it's a well-oriented 1D picket fence or ladder barcode. And what I mean by picket fence and ladder is if you look at a barcode, it's either going to be horizontal if it's picket fence. So literally we call it that because the barcodes, the narrow widths on the barcode look like a wood pallet on a picket fence. So think of that as a horizontal code. A ladder is referring to the orientation where the bars actually look like a rung on a ladder. So that's where that nomenclature came from. But the orientation is going to be very important. So it's either going to be horizontal or vertical, and we want to make sure that's consistent each time. So again, replacing single line laser scanners. Another one is going to be repeatable code placement, and what I mean by that is the distance between your part and the reader needs to be consistent and repeatable each time. So if you have applications where it's very big depth of field and it's varying quite a bit, we want to look at one of our other products. Finally, we want to stay on a continuous read mode, line speed, say 250 feet per minute and below. First I want to get a little bit into the technology of comparing a laser scanner to a vision-based Cognex reader. So we're going to talk about how the technologies differentiate and why that's good for you and your applications. First, this is the world's smallest high-powered industrial reader, and it is vision-based and it is self-contained, so that a lot of times when you have space requirements that are this small, and when I say this small I mean we're looking at 27 millimeters depth and 43.5 millimeters in this direction. So you can package this into very small space constraints, and to do that previously you really would need to go to an external PC. You'd have to put extra cost into powering this, and we're doing that all in this self-contained unit. So outside of the size, the technology behind this and how it's going to differentiate between a laser. If you're not familiar with laser technology, what a laser consists of is a couple of different parts. So there's the laser diode. A laser diode is going to refract off of an oscillating mirror, and there's a motor that drives the mirror. So you have a couple of components there that are moving parts. The reason the oscillating mirror is needed is it turns that single point laser into an array. That array then refracts off of your barcode, comes back to a photo cell, and it is now processed and used for decoding. So you have a couple of components there that are necessary. Now with vision technology, we have very similar to your camera at home. We have an imager and we have a processor. What that means is that we have every single pixel, hundreds of thousands of pixels, available to process and decode your barcodes. And what it also means, which is very important, is that it's solid state with no moving parts. So your cost of ownership is going to be very low compared to a laser scanner. You're not going to have the replacements and the maintenance costs that you will with replacing a laser scanner with moving parts. So we talked a little bit about how the technology works, but now it's very important for you to understand why that's important for you and what it's going to do for your applications. So we have a couple of examples here where you can see there's a single line laser and these 4 scenarios here that are not reading with the laser scanners. Now, if you think about it, you have a code, and you have a single line in which to decode that. So if you have any small deformations, any lighting that's inconsistent, any changes to an optimal code, there's a good chance that you're going to be able to miss that, and you're not going to read that code because of that. Well, with the area array image-based reader, we use all of the pixels to be able to decode that barcode reliably and read it every time, regardless of the damage, the deformation, the uneven illumination, the problems that you have in every manufacturing environment. So you're going to see a lot higher read performance regardless of your code quality. So how do we get that read performance that you would get from an area array imager and make it even better and make it the best reader on the market? Well, we do that with our 1D Max Plus with Hotbar's patent pending technology. These are the algorithms running behind the scene on this processor. And if you think about where Cognex has been as a company, the first DataMan came out 81, 82. We developed our first DataMan, and we were reading OCR back then. So we've been developing algorithms for the past 32 years based on tough industry applications, and we've been improving every year. So a lot of people are coming to market now realizing that vision is the place to be. Well, we own the technology that's really making us stand out beyond anyone else. So a little bit more about Hotbars and why this is good for you. Hotbars really allows us to decode 10 times faster than we ever have. It allows us to use less pixels to decode either the same size barcode or look at smaller barcodes without throwing pixels, resolution, and cost at your application. So now we can do higher speeds, we can handle more deformation of your codes, and we can also we can do larger field of views or smaller barcodes with the same resolution. Now, how do we do that? If we get in a little bit behind the scenes with Hotbars here, we can talk about really the signal fidelity and what that means to decoding reliably. So when I talk about, you see a couple of things here in this slide. There's a 1.5 and a 1.2 number on there. That's pixels per module. Now we use pixels per module to define how many pixels we have available for the smallest minimum bar width on your barcode. So 1.5 would be the industry standard. This is pretty common. You need 1.5 pixels to be able to decode reliably. Now with Hotbars, we only need 1.2. So what does that mean for your application? It means we can look at larger field of views, we can look at smaller codes, we can get bigger depth of field without losing any signal fidelity at all. So really this has put us in a completely different category. So we've talked about Hotbars, talked about why the read performance is so much better, and compared the technology a little bit. Another key point is you have the ability to see what the reader sees. Now what I mean by that is, again, this is a camera. This is taking a picture every time we acquire an image, and then we decode with an algorithm. So if there's something there, there's a picture that's acquired every time. We have a couple of options to be able to make this useful for you. So you can either display that image in real time on an HMI or on a PC, so you can see exactly what the reader's seeing. either on a read scenario or a no read scenario, which is probably more important. So what we'll typically do is customers will use the ability to FTP transfer no read images in an archive for later review. So if I have a line running and I'm at 99.9% and all of a sudden my line goes down to 97%, I need to know what happened. I need to know what happened quickly so I can get the line back up and running, reduce my downtime, and keep my throughput where it needs to be. So what we can do is we can send the images that we've acquired on a no read, and you can review this later and you can physically see that, you know what, it probably most of the time is not an issue with the scanner or the reader itself. It's actually a system level issue. So you may have poor printed codes, you may have the reader being misaligned, someone bumped it, you have an operator that didn't put something on correctly. There's a number of things that can get in the way of a successful read. Being able to see that immediately and problem solve that is a huge benefit to you and your applications. Here's an example here. This actually was not with the 50. This was taken with our 500, but it shows you that you can physically see what's going on with your application. And you see here, not only do we have the image available, we have multiple attempts to decode that barcode, and we can see exactly what happened during that sequence. So this is something that, even though we read these every time, imagine this being a no-read scenario, you can pull these up later, and even if it's in the effort of continuous improvement, you have something to go back, evaluate, make changes, improve your process, reduce your downtime, and increase your throughput. The application that would be good for the DataMan 50L would be a print and apply application. With a print and apply application, you're printing your label, you're applying that to your box or your part, and then you're reading it immediately after. So as long as this standoff stays fairly consistent, you're going to be able to use the DataMan 50L for these type of applications, and you're going to be able to deal with things like poor print quality, low ink, deformation on these parts if you get a dragged applier, and you're going to be able to read them much more reliably with a vision-based 50L. The electronics industry is another big market for the DataMan 50L. So what we're showing here is a very low contrast code that's applied to circuit boards. So these are manufactured in high volume, and it's absolutely critical to be able to read that barcode as it goes by. Now the lasers have a big problem reading low contrast codes, but with the Cognex DataMan 50L, you're going to be able to read that every time. Food is another big industry for this. You see with the example that I have here, the perspective of these gets pretty out of whack. What I mean by perspective is if you have your part here, the angle at which it's presented to the reader can get pretty severe. So that causes a lot of issues out there, but with the Cognex technology, you have no problem reading those. All right, consumer products is another big industry for the DataMan 50L. So the application that we're showing here is, you see the clear plastic, the wrap around that is quite malleable. So not only are you getting code quality issues, but now you're getting reflectance, you're getting deformed codes because the wrap is, it's not sturdy, so it's going to bend and flex. And you also see that there's a clear plastic cover that tends to fall over top of that code. So this is a very, very problematic scenario for a single line laser scanner, and one that we're very, very strong in. So if you have these applications, definitely check it out. Beverage fits in line with your food applications, but again, the codes are pretty consistently placed, but you get high speed, you get large perspective because of the rotation, no problem for the DataMan 50L. So in summary, the DataMan 50L is the world's smallest high-powered image-based reader. Best in class 1D performance with hotbars, patent pending technology. You're going to be able to see what the reader sees by being able to view your images in real time, or FTP transfer to a server for later archives for later viewing. and it's a durable solid state design. So this is going to keep reading much longer than the laser scanners out there with their moving parts. So I'd like to show you a couple of demonstrations that show not only the power of hot bars but also the speed at which these can handle. Alright, so now I want to show the speed capabilities of the DataMan 50L, and there's a couple of things that contribute to this, but mainly we're looking at the power of hot bars and 1D Max Plus. So what I'm going to do here is we just have a demonstration. We're going to be spinning this at very high speeds. We're triggering every time, and we're going to record the total number of triggers versus total number of reads, and then I'm going to actually put my hand in front of it and show you that we're actually counting the number of triggers and calculating no reads. So I'm telling you all this now because it's going to get a little loud here. Last, I want to talk to you about the decoding power of our 1D Max Plus with hot bars algorithms. I want to compare that a little bit to, I'm going to show you some scenarios here that are going to be very problematic for a laser scanner, and in particular a single line laser. So I've got some example codes here of noise, white on black, some damaged codes, some different scenarios that are going to be able to point this out. So first, let's look at a noisy code. And what I mean by noise is that there's a lot of noise in the background. So you're going to see a lot of difference in contrast between the bars in the barcode and the background behind it. So a scenario of this might be ink-jetted code on a corrugated box. You see this quite a bit out there in packaging. Can be very problematic to the signal strength of a laser. So have a code here, some noise on it. I'm going to show you how easy it is to decode with 1D Max Plus with hot bars. Another one here, we have white on black. Now white on black to us, no problem. It can be black on white, white on black. A laser decode, you actually have to tell it which one you're looking at, because if you think of the way it's going to adjust your signal coming in, it's going to be actually inverse for what it's looking for. With the Cognex decode algorithm, you don't have to worry about it. So we have a small white on black code here, decodes right away. Another one I want to talk about, this one happens a lot, is a damaged code. Now a damaged code could mean a few things, but if you look at a single line decode attempt, you're going to have issues if you have any damage as far as the code being worn off, the code having marks on it. Any kind of degradation to the code could be very problematic. But again, since we're looking at every single pixel, we're looking at an array, we're going to be able to decode that quickly every time. Now this one is more not caused to the code being problematic, but the surrounding environment. So you might have a difference in lighting, you might have a fork truck go by, you might have an operator shadowing over the part. These are things that you really can't control, but you need to be very aware of and take account for that in your reader. So uneven illumination, if you think of what this could do to a single line signal coming back, that line is going to be unevenly affected as far as attenuation and fidelity coming back to the processor. So since we do have every single image, we're looking at grayscale, we're not affected by that at all. You see here we decode right away. So those are some examples of code deformation, problems with the code, problems with the printing, things that you might see on the code itself. Another thing I want to talk about are things that you really are not going to be able to control with the barcode itself, but it's system level issues with your angle to the part, with your mounting constraints, and potentially just a need to want to increase throughput on your line. So if you think of the ability to decode at extreme perspective, that can really help you out in all of those scenarios. And with 1D Max Plus with hot bars, we can get up to 85 degrees perspective distortion and still read reliably every time. So you see here we're about 85 degrees perspective. You're not going to be able to get that with a laser system. This is going to help you, like I said, increase your throughput, deal with those really tough mounting constraints, and keep your reading every single time. Last one, this one comes up quite a bit in packaging or bottling. Curved surface applications are very, very tough. Where you're actually bending the code and your code isn't small enough to be within the top of that peak. So I want to show you here with some extreme curves. We're able to read it right away. We're going to read that every time. So in summary, you see the strength of our decode algorithms. Really want to point out that everything that we're doing here is something that you're going to see in your environments. It's going to be very problematic for your laser scanners, something that we have no problem with, and really want you to take a look at the DataMan 50L from Cognex. I appreciate your time.